Does the curve y equal x to the fourth minus 2x squared plus 2 have any horizontal tangents? If so, where? Well, first of all, we know that there would have to be at least one horizontal tangent, because I'm thinking of what I learned from 1050 about polynomials of degree 4, and their left and right hand behavior is like this. And so somewhere they're going to have to have a place where the slope of the tangent is horizontal, because there will have to be a turning point. Now we know x to the fourth could turn at most 3 times, so there could be 3 places, or there might just be one place. So we know to have a horizontal tangent, we'd be interested in where the slope equals 0. So if we take a derivative of this function and we put it equal to 0, the derivative will be the slope, and then we will find any places where the tangent is horizontal because the slope is 0. So let's take a derivative. We've got sums and differences and power rules. So we got power out in front, decrease the power by 1 here, power out in front, get multiplied to the 2 that's already out there and become a 4, and then decrease the power by 1, and then the derivative of a constant, of course, is 0. So now that I have the derivative function, I'm going to set that equal to 0 to find any places where the slope is 0. And this would be factoring out of 4x. I'd have x squared minus 1 equals 0. And so that will leave me 4x, and the difference of squares, x plus 1, x minus 1 equals 0. So in fact, there are 3 places where there's a horizontal tangent: at x equals 0, at x equal -1, and at x equal 1. And we could figure out those points. That would be at the point 0, 2, just putting 0 in this function, at the point -1, and putting -1 in this function, we'd have 1 minus 2 plus 2, so that would be at 1. And then also at the point 1, putting 1 in, we still have a minus 2 plus 2, so that would also be at 1. So we would know that this graph turns 3 times at these 3 points. Let's go ahead and look at the function graphed, and we can see exactly what we found. We found these horizontal tangents at -1, 1, there's our turning point, and at 0, 2, and at 1, 1.